Hello and welcome to section 13.6 on yet even more properties of logarithms. At the top of the worksheet here, I've included all the key properties we're going to look at in this section. And so let's go ahead and first just discuss what each property says, and then we'll work through the first problem on the worksheet. All right, so first property here is what's known as the product to sum property for logarithms. And it says that if I take the log of the product of two quantities, m and n, so I have m times n inside the logarithm, I can split that up as the sum of these logarithms of just m and n, hence the name product to sum. Okay, now I also have this quotient to difference property that says if I take the logarithm of the quotient of two quantities, m and n, then I can split that up as the difference of these two logarithms. And notice here that the first term is the logarithm of this numerator, m, and I'm subtracting from that the logarithm of the denominator, n. Okay, next up we have what's known as the exponent property. So if I have the logarithm of a quantity m raised to the r power, this exponent r can come out in front of the logarithm, and it's going to multiply that logarithm. So in other words, the log of m raised to the r power is equal to r times the logarithm of m. Okay, and then here I've just included the change of base formula that we looked at in the last section just to have all the important key properties for logs in one place for you. Okay, so now let's go ahead and look at question 1. This says, use properties of logarithms to write each expression in terms of the logarithms of x, y, and z. Okay, so for part A, we have log base b of x times y squared. And just for emphasis here, this entire expression x, y squared is in the log. Okay, so like you see in these two examples, you're not always going to see that set of parentheses included. Okay, it's just implied that they're there, and so I'm just going to write them in there to really emphasize, yes, we have the log of this this product here, so we really are going to be thinking product to sum here. And so to start with that property, let's see what we're going to get. So from product to sum, this says take the log of this first factor, which is x, include my base b there, and then I'm going to add to that the log of the second factor, which is y squared. Okay, so that's product to sum. And now notice I have the logarithm of y raised to the second power. Okay, so taking the log of something raised to an exponent, I can then go ahead and rewrite that using this exponent property. This 2 can come out in front of this logarithm, and that then will give us log base b of x plus, and that 2 is going to multiply the log base b of y. All right, and that will do it. How about part B? Well, again, I'll just go ahead and put these parentheses in just for emphasis. So what can I do here? Well, I have a quotient inside the logarithm, right? So I'm thinking quotient to difference. And quotient to difference says this can be broken up as the log base b of the numerator, which is x, minus the log base b of the denominator, which is y squared. Okay, now just like in part A, since I see that y is being raised to the second power, I can then go ahead and pull that exponent of 2 out in front of that logarithm. And so this will give us log base b of x minus 2 log base b of y. All right, and that'll do it for that one. So let's go ahead and move on to part C, we got log base 3 of 9 over x, and then that quantity is being squared. Okay, so again, I see there's this exponent of 2. So I'm going to go ahead and pull this out in front. So this is going to give us 2 times log base 3 of 9 over x. Okay, and now notice that this log base 3 of 9 over x, I can apply the quotient to difference property there and split that up. So I'll go ahead and do that. I'm going to get log base 3 of 9 minus log base 3 of x. But now be careful here. This 2 is multiplying this logarithm. And as we just said, this logarithm is equal to this difference. So what is this 2 going to do in relation to this difference? It's going to multiply this entire expression. So I'm going to put some parentheses there just to emphasize that that 2 is multiplying this entire thing. All right. Can I take this any further? Well, I can in this instance, because notice log base 3 of 9, I can simplify this because see 9 is 3 squared. So let's do this just off to the side. I can do it over here. So for log base 3 of 9, we're asking 3 to what power is 9? And that, of course, is 2. So our logarithm here, log base 3 of 9, is just 2. So if we go ahead and put that in, I'm going to get 2 here minus log base 3 of x, and then this 2 is multiplying this entire expression, and there is as far as I can go. Now if you were to go ahead and distribute this 2 and get, it'd be 4 minus 2 log base 3 of x, that would be perfectly fine as well, but there's no need to distribute the 2. All right, great. Part D, we got log base b of the quantity x, y squared. So I see this exponent here. Let's go ahead and bring this out in front. So this is going to give us 2 log base b of x times y. And now just like what we saw in part C, I can split this up. This is going to be log base b of x plus log base b of y. So I'm using product to sum on this. But again, there's that 2 out in front that's multiplying this logarithm here in blue. So that means it's going to multiply this entire expression. And that is as far as I can go here. All right. Part E, log base b of the quantity x minus y cubed. Well, got this exponent, so I can use that exponent property to bring it out in front. So I'm going to get this. Okay, and now be really careful here. There's this sort of temptation to want to split this up, right? But you got to be really careful in the sense that, hey, what's the operation in here? It is not a multiplication, and we don't have a quotient. There's not a division. This is a subtraction. So there's a little warning here. Okay. Log base b of, say, a plus or minus b, this does not break up in this kind of way, right? Because the operation inside here is either going to be a plus or a minus. Here it's a minus. But in order to apply these properties, right, they take products to sums and quotients to differences, right? none of these properties say anything about what a logarithm would do to a difference. And in fact, there's not any general property that is particularly nice along these kinds of lines. So this is really where we stop. Okay, cool. So f, the log of the square root of x times y cubed. Again, you don't have parentheses there. I'm just going to put them in for emphasis. And we have this product here. The square root of x is multiplying the y cubed. So to begin, let's go ahead and just apply the product to sum. So get the log of the square root of x plus the log of y cubed. Okay, now you might say, well, I think I'm done here with log of square root of x. Be a little careful though, because what is the square root of x? It is x to the 1/2 power. So in fact, I can take this a step further by applying the exponent property here, both to this first logarithm, the 1/2 can come out in front here, and then I can also apply it to this logarithm here and bring this 3 out in front of that logarithm. And so this is going to give us 1/2 log x plus 3 log y. Okay, so that's as far as I could go there. G, log base b of the square root of x squared plus y squared. Well, just like we saw in part F, a square root is really the same thing as putting that quantity to the 1/2 power. So here in part G, I could start by saying, well, this is the same thing as log base b of the quantity x squared plus y squared to the 1/2 power. And now this 1/2 power, that can come out in front. And so that's going to give us 1/2 log base b of x squared plus y squared. Okay, so then this is another place you got to be really careful. Okay, again, it's a bit tempting to want to break this logarithm up, kind of like I was saying here, but right, we have a sum inside the logarithm, so I can't break it up along these lines, right? These properties say what logs will do to products and what they'll do to quotients, not to sums. Okay, the other thing to really be careful about is, yes, there are exponents here. And so you might say, oh, can't I just bring those exponents out in front? No, we can't do that either. Why? Well, because of this addition sign again. This addition sign throws that off because see, this exponent property says if you have the log of an expression raised to a power, then that power can come out front. But I don't have a single expression raised to a power, right? I have something raised to a power plus something else raised to a power. So that does not fit this form here for the exponent property. So in fact, this is where we have to stop. Okay, we're done right there. Okay, great. So just a few more here. Go ahead and look at H next. This one kind of messy, right? I'll go ahead and put these parentheses in. And so to start, notice I do have a quotient. I have this messy numerator, and then that's divided by this denominator of x plus y. So let's go ahead and split that up using the quotient to difference property. So this would be log base b of this numerator, x, y, z cubed, and then minus the log base b of the denominator, that's x plus y. And now cube root. Okay, well, cube root is the same thing as something. Let's make a little note over here. So the cube root of something is just the same thing as taking that expression and raising it to the 1/3 power. Okay, so this would be x, y, z cubed to the 1/3 power, and then I'm subtracting the log base b of x plus y. Okay, and now this 1/3, this exponent, this can come out in front. So that will give us 1/3 times this logarithm, and I have x, y, z cubed inside that log, and then I'm still subtracting this log base b of x plus y. Okay, what can I do next? Well, for this first logarithm here, I do have a product. In fact, I have 3 factors. I have x times y times z cubed. So this thing right here, I can actually break up as follows. This is going to be log base b of x plus log base b of y plus log base b of z cubed. Whew, okay. And then that 1/3 is multiplying this logarithm. So in turn, it's going to multiply this entire expression. And then I'm still subtracting from that log base b of x plus y. Anything more I can do? All right. Yeah, there is. This 3 right here. This can come out in front of this logarithm, and it's going to multiply. So when all is said and done, this is quite the problem here. We've got 1/3 times the quantity, log base b of x plus log base b of y plus 3 times the log base b of z, close parenthesis, and then I'm still subtracting the log base b of x plus y. Okay, and that is where we finally stop. Okay, there's a lot of things going on in that example. Careful also, right? The log base b of x plus y, as we've already noted, right? Cannot split that up. We just leave it as is. Cool. Okay, I and j, they're at least shorter. Log base b of 1/x. Okay, so I could go ahead and start with the quotient to difference, because inside this logarithm, I have 1 divided by x, so I could start there and say this is log base b of 1 minus log base b of x. Now, like what we saw with part C, where we were able to break down this numerical logarithm a little bit further, can we break this down? Log base b of 1. This is saying b to what power is equal to 1? Well, b to the 0 power, right? Because anything to the 0 is equal to 1. So here, the log base b of 1, in fact, is 0. So this is going to equal 0 minus log base b of x. And that then is minus log base b of x. All right, so that does that. And then lastly, j, log base b of 1/b. Okay, again, we have this quotient. So I can break this up and say this is log base b of 1 minus log base b of b. Now, as we've already noted, right, log base b of 1, this is equal to 0, because b to the 0 is 1. What about this logarithm? Log base b of b. Well, for that, b to what power is equal to just b? And that would be b to the first power is equal to b. So this is actually equal to 1. So when all is said and done, I get 0 minus 1, and that's -1. All right, that does it for this question. Thanks so much.